Question number 8. Solve the exponential equation. Express irrational solutions as decimals correct to the nearest thousandths. This is an exponential equation, and in order to solve this, we can use logarithms. We want to get it in the form of b to the t equals r, one base, one exponent, one argument. If we can get it down to the b to the t equals r, then we can convert it to logarithms. To do that, we want to get rid of this plus 2 and this 3 out in front. If we were to simplify so that we have one base, one exponent, one argument, we can rewrite it. So using a little bit of algebra, we're going to subtract 2 from both sides of the equation. That's going to give us 3 times 2 to the x minus 1 power equals 71 minus 2, which is 69. Now I want to get rid of this 3 out in front. I do that by dividing both sides by 3. When you divide both sides by 3, they're going to divide out and you get 2 to the x minus 1 power equals 23. 69 divided by 3, 23. Now we have it in the form of b, one base, one exponent, one argument. We can then now convert to logarithmic form. So we can write this as log, the base is 2, the argument is 23, and that equals x minus 1. We are very close to getting x by itself. We want to solve for x. So our next step would be to add 1 to both sides of the equation. That will give us an x all by itself. On the left side, that's going to give us log base 2 of 23 plus 1. Now, very, very careful here. Do not add 1 to the 23. You have to evaluate log base 2 of 23 first. Get a decimal answer and then add 1 to it. So our x is equal to log base 2 of 23. We're going to use a calculator for that. We're going to do log of 23 divided by log of 2, and then we'll add 1 to get our answer, decimal answer for x. Using the calculator, we're going to evaluate log of 23 divided by the log of 2. We can press enter and that's a decimal, and then we can add 1 to it. So our answer, when we round it to the nearest thousandths, is x equals 5.524. 5.524. And check our answer. So the idea in solving this exponential equation is to simplify it so that you only have one base, one exponent, one argument. Anything else, use algebra to simplify, then convert it to logarithmic form. Okay, let's look at number 9. All right, for this question, we have a logarithmic equation and we want to solve it. And we do that by converting to exponential form. Now, if we have an equation written as one logarithm, a base argument equals an exponent, then we can convert it to here. But we have this 5 out in front. So I want to divide both sides by 5. And I get the natural log of x, as these divide out, is equal to 20 divided by 5, which is 4. This is a logarithmic equation. It's the natural log. This is the same thing as saying log base e of x equals 4. You can then convert this logarithmic equation into exponential form. The base of the logarithm is e, the exponent is 4, and the argument is x. So rearrange the terms to get e to the 4th power equals x. e to the fourth power equals x. Again, we're taking this logarithmic equation, converting it to exponential form. Now we have x by itself. We can use a calculator to evaluate x, which is equal to e to the fourth. And as a decimal, on your calculator, scientific or graphing, locate the e. Oops. Locate. I'm going to press second on my calculator, then e. That gives me e to a power. I'm going to type in 4. E to the power of 4 rounded to the nearest thousandths is 54.598. 54.598. Check. Okay, I'm sorry, but it did say to give the exact answer. I was rounding. I apologize for that mistake. The exact answer is e to the fourth power. So let's try that again. E to the fourth power. I went ahead and used a calculator to get a decimal approximation, but as you can see, I got the answer wrong when I did that. So you do need to put an exact answer here. All right, continuing on, question number 10. This is a logarithmic equation and we want to solve this equation for x. It is in logarithmic form. We want to convert it to exponential form. Now, anytime you have a natural log, that's the same thing as log with a base of e. So you already know that the base is e, the argument is 5x, and the exponent is 7.2. Using the conversion equation, we can write this as e to the 7.2 equals 5x. And we're taking the b, base, the argument, and the exponent, and rearranging those. Now we have e to the 7.2 power equals 5x. We want to solve for x by dividing both sides by 5. So we get x equals e to the 7.2 divided by 5. It does say to give the exact answer here, so I'm not going to estimate this with a calculator. I'm going to do the answer I have is a fraction. E raised to the 7.2 power divided by 5. So the key to solving this is to convert the logarithmic equation to an exponential equation. Okay, question number 11. Solve this logarithmic equation, and it is in the form of log base b of r equals t. The base is 5, the argument is 5x minus 8, and the exponent is equal to 3. We're going to do a conversion here. This is the same thing as the base of 5 raised to the third power equals 5x minus 8. Now this is a simple equation here. Evaluate 5 to the third power. That's going to be 125 equals 5x minus 8. My goal here is to get the x by itself. I'm going to add 8 to both sides. And I get 125 plus 8 is 133 equals 5x. Now we're going to divide both sides by 5 to get our answer. X equals 133 divided by 5. Let's write our answer and check our answer. Okay, so the key to solving this logarithmic equation is to rewrite, find the three parts, the base, the exponent, and the argument, rewrite it so it's in exponential form. Okay, let's look at question number 12. Solve the logarithm. Log base 4 of x to the third plus 37 equals 3. We want to identify the base, 4, the exponent 3, that has to equal the argument. It's in logarithmic form. We're going to convert it to exponential form. So this is the same thing as base of 4 raised to the power of 3 equals x to the third plus 37. All right, let's simplify 4 to the third power. 4 to the third power is 4 times 4, which is 16, times 4, which is 64. So when we simplify this, we get 64 equals x to the third plus 37. We want to get that x by itself, so let's subtract 37 from both sides. And you get x to the third is equal to 64 minus 37, which is 27. So now we end up with the equation x to the third equals 27. The way you get rid of this exponent 3 is by raising it to a power that is the reciprocal. We're going to raise it to the 1/3 power. That's one way to get x by itself. Raise both sides to the 1/3 power. So then that will give us x to the third to the 1/3. Power to a power, you multiply those powers together. And this side is 27 to the 1/3 power. That's also the same thing as the cubed root power. You may use a calculator here to find 27 raised to the 1/3 power. I like to put the 1/3 in parentheses, and you should see that the answer is 3. X equals 3. And check your answer. So the key to solving this one, we take the base 4 raised to the power 3. That has to equal x cubed plus 37. Simplify and solve this equation. We want to get the x by itself, so you have to raise both sides to that 1/3 power. That is how we get our x by itself.